Before any block is laid, before any concrete is mixed, the real strength of a building is already decided, not by the walls, not by the roof, but by what happens beneath the ground. Today, we're going deep into foundation engineering and how professionals select the right foundation based on soil conditions. Every structure stands on a foundation, but not every soil behaves the same. If you get this wrong, the entire building is at risk. If you get this right, the structure gains stability for decades. So let's break it down in the simplest, most practical way for both students and field engineers. A foundation is the part of a building that transfers its load, the weight of walls, slabs, columns, and everything inside, down into the ground. But the ground is not uniform. In one site, you may find strong, dense soil. In another, weak, compressible layers. This variation is why foundation design is never guesswork. It is engineering judgment guided by soil investigation. Let's begin with the types of soil you may encounter on a project. First is rocky soil, the strongest and most stable. It barely compresses, meaning it can take very high loads with minimal settlement. Buildings on rocky soil often use shallow foundations without issues. Next is gravel and coarse sand. These drain well, resist water pressure, and offer good bearing capacity. They are reliable for most small to medium structures. Then we have silt. It is fine, holds water, and compresses easily. If you build on it without proper design, you may experience differential settlement. Next is clay. Clay is tricky. It swells when wet and shrinks when dry, creating movement beneath your foundation. This can crack walls and distort buildings. The most problematic of all is black cotton soil, highly expansive and highly unstable. It demands special foundation solutions. Now that we understand the soils, let's look at types of foundations. Foundations come in two main categories, shallow and deep. Shallow foundations are used when good bearing soil is close to the ground surface. Deep foundations are used when the upper layers are weak and cannot support the load. Shallow foundations include strip foundations, pad foundations, and raft foundations. A strip foundation runs continuously under load-bearing walls, spreading the weight along a long strip of concrete. It's common in residential buildings. Pad foundations are isolated footing pads placed under columns. They look like individual square or circular blocks of concrete, holding each column. They are economical and widely used. Raft foundations, also called mat foundations, act like a giant concrete slab under the entire building. They are used when the soil is weak or the loads are heavy, and individual footings would overlap. A raft foundation spreads the load over a large area, reducing pressure on the soil. Deep foundations include pile foundations and caissons. Pile foundations are long, slender columns driven deep into the soil until they reach stronger strata. They bypass poor soil near the surface and transfer loads to deeper, stronger layers. Caissons or drilled shafts serve a similar purpose but are larger and cast in place. They are used for bridges, heavy structures, and waterlogged sites. Now the key question: how do engineers choose the right foundation for a soil? The decision begins with a soil investigation. This includes test pits, boreholes, and lab tests. From the results, engineers calculate bearing capacity, how much pressure the soil can safely carry. They also check expected settlement, groundwater level, and the nature of the soil layers. Next, the engineer considers the load from the building itself. A single-story house may work with a shallow strip footing. A four-story building may need pad footings or a raft. A high-rise tower or a building on reclaimed land almost always requires piles. Water table also plays a big role. A high water table weakens soil and may require a raft foundation, deeper excavation, or piles. Environmental conditions matter as well. Sites near rivers, coastlines, or areas with seasonal floods need special considerations. Let's look at some practical examples you may face in the field. If the soil is clay, you may use a raft foundation or piles depending on the moisture variation and load. For sandy, well-drained soil, strip or pad footings are often enough. On filled land, soil that has been artificially placed or has debris, piles or raft foundations are usually the safest choice. On black cotton soil, piles, underreamed piles, or raft foundations are preferred because they bypass the expansive upper layer. Finally, what happens when the wrong foundation is chosen? You get differential settlement. One part of the building sinks faster than another. This causes cracks, tilting, and in severe cases, collapse. Water seepage, column failure, and floor buckling are common symptoms. Choosing the right foundation is not guesswork. It is a combination of soil science, structural analysis, and practical field experience. And here is the takeaway. A foundation is not just concrete buried in the ground. It is the invisible engineering that keeps a structure safe, stable, and standing. Every strong building starts with strong soil knowledge and the right foundation choice. That is what separates a builder from an engineer. Welcome to Day 2 of Civil Field Academy, where we bridge classroom knowledge with real-world field practice. If you're serious about mastering civil engineering from the ground up, literally, make sure you subscribe. Like this video and follow the next episodes as we go deeper into real construction workflow from start to finish.